You used about 80 gallons of water today. You didn't think about a single one of them. The shower, the coffee, the toilet you flushed without looking, the pasta you boiled and drained into the sink like it was nothing. 80 gallons, gone. And tomorrow, 80 more will show up like magic. Except it's not magic, it's infrastructure. It's a system, and systems break. Right now, there are 7 major American cities where that system is failing. Not theoretically, not in some climate model collecting dust on a government server. Right now, the reservoirs are draining, the aquifers are collapsing, the pipes are older than your grandparents, and the population, still growing, still moving in, still turning on faucets and assuming water will come out. Here's what keeps hydrologists awake at night. By the time you notice a water crisis, the crisis is already a decade old. The reservoir didn't empty yesterday. It's been emptying for years. You just never looked. Nobody does. Because water is the one thing in your life you never worry about until the morning it isn't there. We built a scoring system, 5 vulnerability metrics, reservoir trends, aquifer depletion rates, population to capacity ratios, 2030 climate projections, infrastructure age. We ran every major US metro through all 5. 7 cities didn't just fail, they collapsed the scale. And here's the part that should scare you. If you live in one of these cities right now, your house is worth what it's worth because of a water supply that may not exist in 4 years. Your job is there because of infrastructure that's cracking. Your kid's school runs on a system that engineers are quietly calling unsustainable. And no one sent you a memo. They won't. That's not how it works. The memo comes when the faucet doesn't. And by then, 4 million other people are reading the same memo at the same time. So let me be the memo. The 5 vital signs. Before we start the countdown, you need to understand the system we used. Otherwise, this is just a list of cities, and lists don't save anyone. Metric 1, reservoir trend. This is the water you can see, lakes, dams, surface storage. Think of it as a city's checking account. If the balance has been dropping for 10 straight years, that's not a bad season. That's a trend. And trends don't reverse because you hope really hard. Metric 2, aquifer depletion. This is the water you can't see. Underground reserves that took thousands, sometimes tens of thousands of years to accumulate. It's the savings account. And here's the dark part. Once you drain an aquifer past a certain point, the rock above it compresses. Permanently. The space that held the water literally collapses. You can't refill a crushed sponge. That water isn't coming back. Not in your lifetime. Not in your grandchildren's lifetime. Metric 3. Population to capacity ratio. How many people are drinking from a system that was built for fewer? It's like cramming 10 people into a 5-person lifeboat. The boat doesn't sink immediately, but every wave gets a little closer to the edge. And Phoenix, by the way, has been adding 70,000 people a year to a lifeboat designed in the 1960s. Metric 4. 2030 climate projections. This isn't a crystal ball. This is what NOAA and IPCC models, and the same models that predicted the megadrought you're currently living through, say about drought, heat, and precipitation for each region through 2030. The forecast, not the hope. And metric 5, infrastructure age, the average age of the pipes, treatment plants, and distribution systems. Old infrastructure means leaks. Some cities lose 30 to 40% of their water to leaky pipes before it even reaches a faucet. Old infrastructure means contamination risk, and old infrastructure means catastrophic failure when you stress it. Some of these cities are running on systems that were built before color television existed. Let that sink in while you're drinking from 5 metrics, 5 vital signs, and the city at the bottom of our list failed on all 5. But we're not starting there. We're starting at number 7, because even number 7 should terrify you. The countdown number 7, Denver, the city running on melting snow, Denver, Colorado, the mile-high city, beautiful mountains, craft breweries on every corner, tech companies relocating by the dozen, fastest growing metro in the interior west, and its entire water supply depends on something that's disappearing, snowpack. See, Denver doesn't sit on a Great Lake. It doesn't have a massive aquifer beneath it. What it has is a system that captures snowmelt from the Rocky Mountains, stores it in reservoirs like Lake Granby and Dillon Reservoir, and pipes it east through tunnels that cut under the Continental Divide. It's an engineering marvel from the 20th century, and the 20th century had a lot more snow. Here's the math. NOAA projects a 15 to 25% reduction in Colorado snowpack by 2030. That's not a worst-case number. That's the median projection. Meanwhile, the Denver metro has added over 500,000 residents since 2010. More people, less snow, same pipes. The Denver Basin Aquifer, their backup, is dropping roughly 2 feet per year. And the Colorado River, which feeds Lake Powell and Lake Granby, it's been in decline for over 2 decades. The bathtub ring on Lake Powell is visible from space. Denver's infrastructure is holding, for now. Average pipe age is about 55 years, with some sections dating to the 1940s. Not the oldest on our list, not the worst. But the city is negotiating from a position of weakness in the Colorado River Compact renegotiations, and every percentage point of water they lose upstream means a percentage point they can't replace downstream. Worst case by 2030? Snowpack drops 25% or more. Colorado River Compact renegotiation forces mandatory cuts. Denver implements Stage 3 water restrictions. No outdoor watering, mandatory rationing, and a demand-supply gap that widens to 20% with no backup source to close it. And through all of this, the population keeps growing. Because nobody moves to Denver for the water policy. They move for the mountains. The irony is, the mountains are the problem. That's number 7. And if that sounds manageable to you, I want you to remember something. Denver is the best-case scenario on this list. It gets worse from here. Number 6. Miami. Death from below. Here's a question that should keep every Miami homeowner awake at night. What happens when the ocean drinks your aquifer? Miami is the only city on this list that could lose its water supply from underneath. Not from drought, not from overuse, from saltwater intrusion, and it's already happening. The Biscayne Aquifer sits under South Florida like a shallow limestone sponge. It's porous, it's fast recharging, and it's the sole drinking water source for over 6 million people in the Miami metro. The problem? It's only about 20 feet below the surface. And the Atlantic Ocean is right there, pushing inland, driven by sea level rise every single day. Right now, the saltwater wedge under Miami-Dade County is advancing at over 1,000 feet per year toward the western well fields that supply the city. That's not a projection. That's a measurement. USGS has been tracking it. 6 to 12 inches of additional sea level rise by 2030, which is the current consensus estimate, accelerates that intrusion past critical barriers that were supposed to hold for decades. They won't. Miami doesn't have major surface reservoirs. There's no backup. There's Lake Okeechobee to the north, but that's already over-allocated, politically contested, and ecologically damaged. The infrastructure is about 40 years old on average, built on porous coral rock that leaks like a colander. And the system was designed for maybe 3 million people. 6 million are drinking from it right now. Worst case by 2030, 6 or more inches of sea level rise pushes the saltwater wedge past the western wellfield barriers. Miami-Dade is forced to abandon its primary extraction points. Coastal neighborhoods start seeing drinking water salinity exceed EPA limits, and the city enters a scramble for alternative sources that don't exist yet. Most people hear water crisis and they think desert. They think Arizona. They don't think Miami. That's exactly what makes this so dangerous. Nobody's preparing for the water problem they can't see. And in Miami, the water problem is literally rising up from below. But at least Miami has rain. At least it has options. The next city on our list, it put 2 million people on one aquifer and then crossed its fingers. Number 5. San Antonio, 2 million people, one straw, San Antonio, Texas. Population, 2 million and climbing fast. One of the top 10 fastest growing cities in America. 20% growth since 2010 and no sign of slowing. And nearly all of it drinking from a single source, the Edwards Aquifer. Let me explain why that's terrifying. Imagine a city of 2 million people getting their water from one well. That well refills when it rains. When it doesn't rain, and in Central Texas, multi-year drought cycles are becoming the norm, not the exception, that well drops, and it drops fast. The Edwards Aquifer has a critical threshold, the J17 index well at 650 feet. Below that level, the Edwards Aquifer Authority triggers mandatory pumping restrictions. They've hit that trigger multiple times in the last decade. Each time, it was closer. Each recovery took longer. San Antonio does have surface water from Medina Lake, but Medina Lake regularly drops below 10% capacity during drought. It's a backup that barely functions as a backup. The city has invested in a desalination plant for brackish groundwater and a pipeline project from other aquifer zones, but these are supplements, not solutions. They can't replace the Edwards at scale. The climate projections for south-central Texas through 2030 are grim. Extended drought cycles, 100-degree days becoming 110-degree days, evaporation rates climbing. And through all of this, people keep moving to San Antonio because Texas has no state income tax and the housing is cheaper than Austin. Nobody checks the aquifer level before signing a mortgage. Worst case by 2030? A multi-year drought drops the Edwards below the 650 threshold and stays there. San Antonio enters Stage 5 restrictions. No landscape irrigation, no car washes, no pool filling, rationed household use. And because the city's growth trajectory assumes water availability that may not exist, the economic shock cascades, construction freezes, property values stall, and 2 million people realize the straw they're all drinking from just hit the bottom of the glass. One aquifer, 2 million people, and a climate that's getting meaner. That's not a water plan, that's a prayer. And prayer isn't a metric, but San Antonio at least has a functioning aquifer for now. Number 4 on our list? Its aquifer is already gone. It just hasn't told anyone yet. Number 4. Tucson, the city that already ran dry Tucson, Arizona. 1 million people in the Sonoran Desert. And here's the thing, nobody in Tucson's real estate market wants you to know. Tucson already ran out of its own water. Decades ago. It's been borrowing ever since. Tucson's local aquifers are 80% depleted. Not stressed, not declining. 80% gone. The groundwater that took millennia to accumulate has been pumped out so aggressively that in some areas the ground itself has subsided, literally sunk, because the rock layers above the empty aquifer compressed under their own weight. That water isn't coming back. The container doesn't exist anymore. So how does a city of 1 million people survive in the desert with no groundwater? Simple. They built a 336-mile canal from the Colorado River to central Arizona. It's called the Central Arizona Project, or the CAP. It's one of the most expensive and ambitious water infrastructure projects in American history, and it is Tucson's lifeline. There is no plan B. Here's where it gets worse. The CAP draws from Lake Mead. Lake Mead is currently at roughly 35% capacity. Its inflows have been declining for 20 years. And under the Colorado River Compact, when Lake Mead drops, Arizona's CAP allocation gets cut first. That's not a negotiation. That's the law. Arizona is the junior rights holder. They drink last. And when there's not enough for everyone, they're the first to go thirsty. Arizona already took Tier 1 cuts. If Lake Mead drops below 1,000 feet, and the trajectory says it could, Tier 2 cuts reduce Tucson's CAP allocation by 30 to 40%. Tucson, a desert city with no local water, losing a third of its imported supply because a lake 300 miles away is draining faster than it fills. And then there's the infrastructure itself. The CAP Canal is a single system. One canal. 336 miles of open concrete channel crossing the Arizona desert. One failure point. One earthquake, one collapse, one contamination event. And Tucson is dry, not in weeks, in days. The climate projections? Sonoran desert temperatures are climbing. 120-degree days are increasing by 40%. Evaporation is accelerating at both ends. At Lake Mead and along the canal itself, Tucson is losing water to the air before it even arrives. Worst case by 2030? Lake Mead drops below the 1,000-foot threshold. Tier 2 or Tier 3 cuts strip Tucson of its primary water source. Residential rationing begins. Agriculture in Pinal County, which has already lost most of its allocation, collapses entirely. And 1 million people in the desert confront a reality that geologists have been whispering about for decades. Tucson was never meant to be this big. Tucson ran out of water years ago. It's been on life support from a canal that's losing its source. But at least Tucson only imports from one place. Number 3 on our list imports from 3 different sources, and all 3 are failing at the same time. Number 3, Los Angeles, 4 million people, 0 local water. Los Angeles, 4 million in the city, 13 million in the metro, the second largest city in America. And 85% of the water that comes out of every faucet, every shower, every fire hydrant in LA was imported from somewhere else. Let that number settle for a second. 85%. LA barely has any local water. The San Fernando aquifer is contaminated and depleted. The LA River is a concrete channel that hasn't been a meaningful water source in a century. Almost every drop that keeps this city alive arrives through 3 systems: the Colorado River Aqueduct, the State Water Project from the Sacramento Delta, and the LA Aqueduct from the Owens Valley. 3 lifelines, and all 3 are under existential stress at the same time. The Colorado River Aqueduct. You already know the story. Lake Mead declining, compact renegotiation forcing cuts. California has senior rights compared to Arizona, but that doesn't mean unlimited water. A 15 to 20% reduction in California's Colorado allocation is on the table. For LA, that's millions of acre-feet they can't replace. The State Water Project. This brings water from Northern California's Sacramento-San Joaquin Delta, pumped over the Tehachapi Mountains. In drought years, the SWP allocation has dropped as low as 5% of contract amounts. 5%. That's not a typo. And Sierra Nevada snowpack, which feeds the entire Northern California reservoir system, is projected to decline 30% by 2030. The LA Aqueduct, the oldest of the three, dating to 1913. It drains the Owens Valley, which is now an ecological disaster area. Owens Lake is a dry lakebed, one of the largest sources of dust pollution in America, because LA took its water. The aqueduct still operates, but its yield is declining and politically contested. Now add infrastructure. LA's Department of Water and Power operates a system with an average pipe age of over 70 years. Some of the mains in the oldest neighborhoods date to the 1920s. Every year, there are thousands of water main breaks across the city. Thousands. Each break is water lost. Water that was imported hundreds of miles, pumped over mountains, treated and then leaked into the ground before it reached a faucet. Worst case, by 2030, the Colorado Compact reallocation cuts LA's share by 15 to 20%. A simultaneous drought year drops the state water project allocation to single digits. Sierra snowpack collapses, and LA enters emergency rationing, 50 gallons per person per day. No landscape irrigation, no car washing, mandatory reduction for commercial use. 13 million people in a basin with almost no local water, watching 3 aqueducts deliver less and less every year. Los Angeles is the most water-dependent city in America that nobody thinks of as water-dependent. 85% imported, 3 failing sources, 70-year-old pipes, and 13 million people who turn on the tap and assume it'll work tomorrow. But at least LA has diversity of supply, even if all 3 are declining. Number 2 on our list, 90% from one lake. One single shrinking, dying lake. Number 2, Las Vegas. The empire the desert wants back. Las Vegas, a city that shouldn't exist. 2.2 million people in the Mojave Desert, surrounded by nothing but rock, sand, and heat that cracks asphalt. And over 90% of their water comes from one place, Lake Mead. Lake Mead, the largest reservoir in the United States, built in the 1930s behind Hoover Dam, designed to hold 9.3 trillion gallons of water, and right now it's sitting at roughly 35% capacity, the lowest it's been since it was first filled. That white band you see on the canyon walls around the lake, that's the bathtub ring. It's over 170 feet of missing water, exposed like a scar. Now, Las Vegas has done something remarkable. In 2020, the Southern Nevada Water Authority completed the third intake straw, a $1.5 billion tunnel bored through the lakebed to access water at the lowest possible level. It's an engineering feat. They literally drilled a straw into the bottom of a dying lake because the first 2 intakes were about to suck air. That should tell you everything about the trajectory. Las Vegas also leads the nation in water recycling. Nearly every drop of indoor water that goes down a drain in the Vegas metro is treated and returned to Lake Mead. They've ripped out ornamental grass across the city. They've implemented some of the strictest conservation measures in America. And it's still not enough. Because the problem isn't Vegas's consumption. The problem is the Colorado River itself. The Colorado River is allocated to 7 states and Mexico under a compact that was written in 1922, a year that we now know was one of the wettest in the last 1,200 years. The entire water allocation system for the American West is based on a fluke wet year. Every state was promised water that doesn't exist. And Lake Mead is where the shortfall shows up. Inflows to Lake Mead have declined by 20% over the last 2 decades. The megadrought gripping the Southwest is, according to tree ring analysis, the worst in at least 1,200 years. And NOAA's projections through 2030 show it intensifying, not easing. There's a number that haunts every water manager in Nevada, 895 feet. That's the dead pool elevation of Lake Mead. Below that level, water can't flow through Hoover Dam. The dam stops generating power. The lake becomes a puddle trapped behind concrete. Even the third straw has limits at extremely low levels. And right now, the lake's surface is closer to that number than it's ever been. Worst case, by 2030, Lake Mead drops below 900 feet. Hoover Dam goes silent. Las Vegas loses its primary water intake despite the billion-dollar straw. The casino industry, the economic engine of the entire region, faces shutdown. Property values collapse, insurance companies flee, and 2.2 million people in the hottest, driest major metro in America discover that conservation doesn't matter when the lake itself is gone. Las Vegas built an empire in the desert, and now the desert wants it back. They've fought harder than any city on this list. They've innovated more. They've spent more, and it still might not be enough. Because you can't recycle water that isn't there, but there's one city left. A city that scores critical on all 5 of our metrics. A city where the growth hasn't slowed, the water hasn't arrived, and the warning signs are already turning into consequences. Number 1, Phoenix, ground zero. Phoenix, Arizona, the fastest growing city in the United States. 5 million people in the metro. 750,000 added since 2010 alone. More people moved to Phoenix in the last decade than live in the entire city of Denver. And every single metric we measured, every one, is flashing red. Let's walk through it. Reservoir trend. Phoenix draws from 2 systems, the Salt River Project, which manages local reservoirs like Roosevelt Lake and Saguaro Lake, and the Central Arizona Project, which brings Colorado River water from Lake Mead. Both systems are in long-term decline. Roosevelt Lake has hit historic lows. Lake Mead, you've already heard that story. Phoenix's surface water sources are shrinking on both ends simultaneously. Aquifer depletion. This is where Phoenix separates from every other city on this list. In some areas of the Phoenix metro, groundwater is being pumped out at 3 times the rate it's being recharged, 3 to 1. For every gallon that seeps back into the ground, 3 gallons get pulled out. The water table in parts of Maricopa County has dropped hundreds of feet. And unlike Tucson, Phoenix doesn't have a century-old cap recharge program to soften the blow. They've been pumping and growing, and the math has finally caught up. Population to capacity. Phoenix is adding people faster than it's adding water infrastructure. The system was designed in the mid-20th century for a fraction of the current population, and unlike coastal cities that can pivot to desalination, Phoenix is landlocked. There is no ocean. There is no Great Lake. There is no new source of water within economic reach. What they have now is what they get, and what they have now is declining. Climate projections. The Sonoran Desert around Phoenix is projected to see a 40% increase in days above 120 degrees Fahrenheit by 2030. 120 degrees. At those temperatures, evaporation rates from reservoirs and canals accelerate dramatically. You're losing water to the air before you can use it, and precipitation declining. The monsoon season, which used to provide a meaningful recharge pulse, is becoming shorter and less reliable. Infrastructure. Phoenix has newer construction in the suburbs, but the Salt River Project canal system, the backbone of the city's water delivery, is a single point of failure network. One major canal breach, one contamination event, one infrastructure collapse, and large sections of the metro go dry. Not next year, that week, and here's the proof that this isn't theoretical. In 2023, Arizona's state government quietly halted new construction approvals in parts of unincorporated Maricopa County. The reason? Insufficient groundwater to support new development for the next 100 years, which is the legal requirement under Arizona's Groundwater Management Act. They couldn't certify the water, so they stopped the building. Think about that. The fastest growing metro in America had to stop building houses because there isn't enough water to drink from them. That wasn't a climate activist making a point. That was the state government doing math and not liking the answer. Worst case by 2030? It's not really a worst case. It's a convergence. CAP cuts reduce imported water. SRP reservoirs stay low. The aquifer keeps dropping at 3 to 1. The population keeps growing because people keep moving to a desert with cheap houses and sunshine, not realizing they're buying into a system that is structurally failing. And at some point, maybe 2028, maybe 2029, maybe 2031, Phoenix becomes the first major American city to face genuine structural water unviability. Not a drought, not a bad year. A permanent mismatch between supply and demand. 5 metrics, 5 failures, no backup, no coastline, no margin. Phoenix is ground zero. The proof. It already happened right about now. Some of you are thinking, this is worst case stuff. It won't actually happen. Fair enough. Let me show you 3 places where it already did. Cape Town, South Africa, day 0 in 2018. Cape Town, a modern, wealthy, developed city of 4 million people, came within 90 days of becoming the first major city in the modern world to completely run out of water. They called it Day 0, the date when the municipal water supply would be shut off entirely. Residents were limited to 50 liters per day. That's about 13 gallons for everything. Drinking, cooking, bathing, flushing, 13 gallons. The average American uses 80 to 100 gallons a day. Cape Town was rationed to an eighth of that. The military was on standby to distribute water from 200 collection points across the city. People waited in lines for hours. Neighborhoods turned on each other, businesses collapsed, property values cratered. They avoided day zero, barely. A combination of emergency conservation, agricultural water transfers, and, frankly, luck with late-season rainfall pulled them back from the edge. But the lesson was permanent. A modern, functional first-world city can run out of water, and every city on our list today is closer to that edge than Cape Town was 2 years before its crisis. Flint, Michigan. When infrastructure kills. Flint's crisis wasn't about running out of water. It was about what happens when the pipes fail. When Flint switched its water source to the Flint River to save money, corroded pipes leached lead into the drinking water of 100,000 people. Children were poisoned. Blood lead levels spiked, and the government knew for months before it told anyone. Flint is the infrastructure metric in action. Metric 5. When your pipes are old, your treatment plants are underfunded, and your oversight is compromised, the water that comes out of the tap isn't just scarce, it's toxic. And remember, some of the cities on our list are running on infrastructure older than Flint's. Jackson, Mississippi, the system that just quit. In August 2022, 150,000 people in Jackson, Mississippi woke up to no water pressure, nothing. The O.B. Curtis water treatment plant failed after flooding overwhelmed a system that had been crumbling for years. For weeks, residents couldn't drink from the tap, couldn't flush toilets, couldn't fight fires. Jackson wasn't in a desert. It wasn't facing a drought. It had plenty of water. It simply had a system too old and too neglected to deliver it. One bad storm, one overloaded plant, and the whole thing collapsed. Now imagine Jackson at the scale of Phoenix or Las Vegas. Imagine 5 million people waking up and turning the tap. Nothing. Not because the water dried up, because the system that delivers it finally gave out. Cape Town, Flint, Jackson, 3 cities, 3 different failures. Scarcity, contamination, collapse. And every single one of those failure modes is present in the 7 cities we just counted down. This isn't theoretical, it's historical. And history, as they say, doesn't repeat, but it sure does rhyme. The response, what you actually do now. All right, deep breath. I've just walked you through 7 cities, 5 metrics, and 3 case studies that prove this isn't speculation. So what do you actually do with this information? 3 things. First, know your source. This is the simplest thing you can do, and almost nobody does it. Go to your city's water utility website. Search for the Consumer Confidence Report. Every municipal water system in America is required to publish one annually. It tells you where your water comes from, what contaminants have been detected, and how old the system is. Read it. If your city sources more than 50% from a single declining source, that's a red flag. If the report mentions aging infrastructure with deferred maintenance, that's a red flag. Most people have no idea where their water comes from. Don't be most people. Second, build a water buffer. The federal recommendation is 1 gallon per person per day for a minimum of 2 weeks. That's 14 gallons per person. A family of 4 needs 56 gallons. Start there. Get food-grade water storage containers. Not old milk jugs, not leftover soda bottles. Proper containers. Treat stored water with 2 drops of unscented household bleach per quart. Rotate every 6 months. And if you can scale up to 30 days, do it. Because when Cape Town hit day zero conditions, 2 weeks would not have been enough. Third, factor water into major life decisions. If you're buying a house, relocating for work, or choosing a place to retire, look at the water stress rating. The World Resources Institute has a free tool called Aqueduct that maps water stress for every region on the planet. Check it before you sign anything, because a $300,000 house in a city with no water isn't an investment. It's an expensive tent. You can't control the Colorado River. You can't refill an aquifer. You can't stop 2 million people from moving to Phoenix. But you can know the risks, prepare for the disruption, and make decisions based on data instead of assumptions. If this video opened your eyes, hit subscribe. We put out science-backed survival analysis every single week. No panic, no politics, just data.